अस्सलाम वालेकुम डियर स्टूडेंट्स। जो आज हमारा टॉपिक है दैट इज अबाउट कोलम गेज। तो हमें देखना है कि कोलम गेज होता क्या है। सो व्हाट इज इट इज फिजिकल सिग्निफिकेंस इन electrodynamics. So first of all, let us write that we have these we can write that magnetic field as. So this is how we define electric field. हम कैसे लिख सकते हैं? That is, you can write in terms of that vector potential, gradient, this curl of that vector potential. And similarly, we can write the electric field as combination of that scalar potential as well as vector potential. So that means everything we are writing that electric as well as magnetic field in terms of that potentials means phi and E, right? Now, this this is the way. So the above equation is a way to write how to write this electric and magnetic field in terms of these potentials, scalar and vector potential, right? Now there's a there's we can transform. So we can choose now some transformation like if we have अगर हमारे पास phi होगा so we can transform it to phi plus some scalar quantity. And similarly, A we can choose, we can transform into A plus some delta, right? So this is basically, as I already told you, this vector potential it is not uniquely determined. So हम इसको कुछ पैरामीटर ऐड कर सकते हैं. So that means we can write the potential plus the gradient of some constant value. So while this value of this lambda is changing very quickly, so that is what this gradient of lambda indicates, right? Similarly, अगर हम phi देखेंगे, phi को भी हम रिप्लेस कर सकते हैं टू phi प्लस lambda. तो इससे क्या हो जाएगा? सो फर्स्ट दैट इज, तो दैट मीन्स जो अगर हम इसको कुछ पैरामीटर ऐड करेंगे टू आवर स्केलर पोटेंशियल एंड सिमिलरली वी ऐड सम दिस some constant term to this vector potential, but the final equations that is electric as well as magnetic fields वो constant है, so they remain the same, right? So this is very important. So we are basically transforming some this potential to some new value, right? And similarly this phi. So we can prove that. So if I now check, तो अगर मैं यहाँ पे check करूँगा whether I should get the same B or not. So let us use this A in this equation that B equal to lambda cross A. So if I write this B as, okay, तो मैंने सिंपली यहाँ पे क्या किया, I expand this, so this will be lambda cross A plus that lambda cross this gradient. Okay, so if you check this, so this is, if you know that from our basic that the curl of the gradient will be 0. So that means I am getting here that B should be equal to, it should be equal to that lambda cross A. This is some new potential. This magnetic field, that's our B dash. So that means B dash should be equal to B. So that means जो हमारा मैग्नेटिक फील्ड है, अगर हम इसको ऐड भी कुछ पैरामीटर ऐड करेंगे तो वेक्टर और स्केलर पोटेंशियल और फाइनल इलेक्ट्रिक एंड मैग्नेटिक फील्ड रिमेन्स इनवैलिड, right? Okay. And similarly, if I have a look on the other side, so similarly, if I go for this equation, so this was, तो यहाँ पे हमने देखा कि जो मैग्नेटिक फील्ड हमारा है, it remains invariant, it remains constant, and similarly, this E you can write as, okay, तो हम इस इक्वेशन में हम देखेंगे whether this electric field remains same, it remains unaffected or not. So let's check. So if we calculate its value, so this will be okay. So this term will be zero because this nebula is basically partial by partial x. That is, it is our that in this it's our Laplacian operator, right? तो अगर हमें एक्ट करेंगे किसी कांस्टेंट पे तो दिस टर्म शुड बी इक्वल टू जीरो, ये आपको पता है. So that means we should get here, so minus lambda phi, and this term will always be zero because this lambda is again constant. When you vary it with respect to time, so this will be equal to zero. So this term will be zero, and this term will be equal to zero. So this will be minus partial a. So that's equal to. So that means we're basically, so this is basically we're writing that we're adding some potential, we're adding potential to some value, like we have phi plus lambda phi, and similarly we are adding some parameter to that vector potential, but our final equation is those remains unaffected, that electric as well as magnetic field, right? Now if I have a look on the other two equations, because I can write the Maxwell equations in elect this scalar as well as the vector potential. तो हम जो हमारी Maxwell equation उनको भी हम लिख सकते हैं in terms of that scalar and vector potential. तो okay, so that means we have two equations. So first equation is that is nebula square phi. Okay, so these are our Maxwell equations. So those four Maxwell equations, you can combine them and write it in this compact form, right? तो ये हमने Maxwell equation जो हमने लिखी है यहाँ पे, we wrote those Maxwell equation in terms of that scalar and vector potential, right? So you can see here, so this is our scalar potential, vector potential, and this is our charge density, and epsilon naught, this is uh, that constant, and similarly this phi and j is our current density, mu naught and epsilon में mu naught, right? तो दैट मीन्स हम इनको क्या कर सकते हैं, बिकॉज दीज इक्वेशंस दीज आर कपल्ड इक्वेशंस. तो यहाँ पे जो हमारा स्केलर एंड वेक्टर पोटेंशियल है, दीज आर कपल्ड, so these are related. So you can have in one equation you have this scalar as well as vector potential, and similarly you have this phi as well as a, right? तो इनको हम separate करने के लिए, in order to decouple them, so because these two equations are inhomogeneous equations, because there is source charge present. We have that current density here, here we have that charge density, right? So these equations are second order differential equations as well as inhomogeneous equations, right? And one more thing that we need to decouple them. हमें इनको separate करना है. So we need to write one equation is phi separately. We need to write that vector potential separately, right? तो उनको separate करने के लिए, so we are using some condition that is called gauge condition, or you can say that we impose that's basically called that Coulomb gauge. So Coulomb gauge is basically we if we impose that nabla dot a vector should be equal to 0. Okay. तो व्हाट डज दिस इंडिकेट? तो ये हमें कह रहा है कि अगर हम फॉर एग्जांपल जो हमारा वेक्टर पोटेंशियल है, तो वेक्टर पोटेंशियल जो है इट इज नॉट यूनिकली डिटरमाइंड, तो ये इसका यूनिक वैल्यू नहीं होता है. So because if you choose that vector potential, you can write it in terms of that you can write that some a in terms of that a plus some gradient of some scalar function, some constant, right? Okay. So that means at different points this potential has